Okay, so we will continue with the problems. Let us consider the following problem. The spring held follower AB has a weight W and moves back and forth as its end rolls on the contoured surface of the cam, where the radius is R equals to where the radius is R and Z is equal to A sine 2 theta. If the cam is rotating at a constant rate theta dot, determine the force at the end A of the follower when theta becomes equal to theta 1. In this position, the spring is compressed with a certain distance delta 1. Neglect the friction at the bearing C. So what is happening here? In this problem, you have this is a cam, okay? And what is the purpose of the cam? As you can see here, you have a certain shape in a way that when you are in contact with a point, when you have the rotation, this distance will be varying, okay? So this is why when you rotate your cam, the spring will go back and forth, okay? Because here you don't have a constant level. If it was just a simple cylinder, even if you rotate the cylinder, point A will remain at its place. But since you have here a certain profile, okay, then this distance is varying as you have rotation. So the spring will go back and forth, okay? Now, they helped us here. They gave us the equation of the profile. So this distance here, Z, they call it Z. The distance Z is depending on the angle of rotation. So as theta will increase, as we have rotation, Z will vary, and then the spring will go back and forth. It's a sinusoidal function, so you will have a certain motion that will be, if you want, it's alternating between going back and forth like this. So the spring will be oscillating, if you want, around a certain position. So now what we will do, the question is to determine what is the force acting on A when the angle of rotation is equal to theta 1. Theta 1 is 45 degrees. And we know that for this corresponding angle, the spring is compressed a certain distance delta 1 equals to 0.4. Okay? So now the purpose is to determine what will be the force acting on A. Since we are asking for a force, we should think about the Newton law. So whenever they ask you for a force, you should draw the free body diagram and try to write the equation giving the force. So what do we have here? We have the force of the cam on the follower, and we have, from the other hand, we have the spring force. Okay, since the spring is compressed, then it will act on the follower in this way. So this is force of the spring. And since our follower is just going along Z, it's moving along Z, so we have a 1D problem. It's one-dimensional motion because it's just going back and forth in one direction. So all forces acting on it are along Z. We have the force of the cam on it, and we have the spring force. So simply to get F, we should write that sum of forces along Z on the follower is equal to its mass times the acceleration along Z, AZ. Okay? And now, in order to determine what is the value of F, so let us project on Z. We have plus F to be determined, minus the spring force, F spring, equals to the mass of the follower times AZ. But how to find AZ? This is the question, because here the spring force, I can calculate it as K times delta L. So it's K times delta. And concerning F, I don't know it. So it's just, already I have one unknown. So I need to determine what is AZ to be able to calculate F. How can I find AZ, do you think? What should I use to calculate the acceleration in Z? what is the information in the given that will help me to calculate AZ? Any idea? So as you can see here, Z is given function of theta. So you have that Z is equal to A sine 2 theta. And since AZ is defined as the second derivative of Z with respect to time, then in order to find the expression of AZ, we should derive Z first. The first time with respect to time, we get Z dot, which is the velocity along Z. So Z dot is equal to VZ is equal to A is a constant, and this is a function of theta. So in order to derive with respect to time, I should use the chain rule. The chain rule will give me that A times the derivative of sine 2 theta is 2 cosine 2 theta. And using the chain rule, I should not forget to multiply by d theta by dt, which is theta dot. So this is the expression of the velocity. Now, in order to get the acceleration, I should derive another time with respect to t. So I will get that z dot dot is equal to, now I have to derive this term, okay? I have two functions, cosine 2 theta, which is u, and theta dot, which is v. But they said here that theta dot is constant. So if it was not constant, then they should provide me with the angular acceleration theta dot dot, so I can calculate the value of the derivative. But since theta dot is constant, so I can treat it not as, it's not a function anymore, so it's just a constant. So now I only have to derive cosine 2 theta. So z dot dot will be equal to the constant, which is 2a theta dot, times the derivative of cosine 2 theta. We know that the derivative of cosine 2 theta is minus 2 times sine 2 theta. And this is the derivative with respect to theta. In order to obtain the derivative with respect to time, we should not forget to multiply by theta dot. So then we will obtain that now z dot dot is equal to, so z dot dot is simply equal to minus 4a times theta dot square times sine 2 theta. And then all you have to do now is to replace theta by its value. You have the value of theta dot, you have the value of theta 45 degrees, and you have a equals to 0.1. Replacing, you get the value of z dot dot. Once we have z dot dot, we can replace back into Newton equation to get the only unknown, which is the force of the cam on the follower. And this was the question. Okay, so in this way, we can determine the force at the end A for the angle that they asked for theta equal 45. Okay, any question on this?
دكتور كيف الديريفاتيف طلعت معك رجعت نيجاتيف؟
Can you please repeat the question?
How did the derivative of z prime طلعت negative؟
Okay, look, هي مش قصة هي negative. ما أنت عندك sin 2 theta can be positive or negative. يعني أنت حيكون في phases of acceleration and other phases of deceleration. It depends on the value of 2 theta. اتفقنا؟ يعني for example, when theta is equal to 45 حيصير عندي هون sin 2 theta is positive, it's 1, بتكون deceleration. For other angles, يعني إذا بتاخد for example, you know that if we draw the circle of trigonometry, we know that sine is positive for theta between 0 and 180, and it's negative for angles between 180 and 360. So here you have rotations. So when theta is between 0 and 180, or a certain multiple of them, because it's a periodic, it's plus 2 k pi. Okay. So whenever theta is between 0 and 180, sine 2 theta will be positive, and then z dot dot will be negative. Okay. So you are having in this case, to test if it's deceleration or not, you should compare the sign of A to V. Because if you remember, when we talked about acceleration and deceleration, what was the condition? Vz times Az should be positive to have an acceleration, and Vz times Az should be negative to have a deceleration. Okay? So you can check that, for example, if you look at the expression of Vz, Vz is proportional to cosine 2 theta. Okay? Cosine 2 theta will be positive in which interval? So for example, if you have theta from 0 to 45, what will happen for cosine 2 theta? Cosine 2 theta will be positive, and also sine 2 theta will be positive. So you can say that from 0 to 90, I have acceleration. It's an acceleration phase. Now, from 90 to 180, what will happen? Cosine theta will change in sign. Okay, cosine theta. Sorry, here we have minus before AZ. So since we have minus before, then here it's deceleration from 0 to 45. Okay, from 45 to 90, what will happen is that cosine 2 theta will change sign, while sine 2 theta will remain with the same sign. Okay, therefore you will have from 90 to 180, you will have that Vz is negative, and also z dot dot is negative, Az is negative. Then since both are negative, then you have an acceleration phase. Okay, so you have alternation here between deceleration and acceleration. This is why you can have positive or negative values. Okay,
All right, thank you.
welcome. Any other question? Okay, thank you guys. So we are done with chapter 13. Next time, hopefully, we will do together problems on chapter 14 and we'll be done. Okay. And if you have any questions, you can contact me anytime. Have a nice week and bye.